Top of the morning, Dr. White here, and we're going to be starting our new unit on circuits. The first lesson I wanted to kind of talk about sort of the background of electricity, right? Where electricity comes from. You guys have electricity all around you, okay? It's very important to modern day life, but I thought we could think a little bit about sort of where it comes from. I wanted to show you sort of a demonstration. So I've got two pieces of magic tape here stuck together, like top to top, like kind of like that. And I'm going to pull them apart really quickly, and I want you to observe what happens here. Okay, so we put them together. You can kind of see what's happening here, right? I'm just kind of putting them together, and they have some sort of an attractive force. What I'm going to do is I'm going to try to do this experiment here. I'm going to take another two pieces of tape, and I'm going to do the same thing. Going to take my two pieces, right? And we observe the same thing, right? Obviously, okay, same experiment, same result, right? But now I'm going to change it up a little bit. I'm going to take the top from one experiment, and I'm going to grab the top from the other experiment, and I want you to see what happens here. You guys see what's happening? Sorry, I'm trying to get this in a way that like we can see it a little bit better. You guys see how they're actually repelling? Okay, and if you're going to do the same thing with the bottoms of the two pieces of tape, you'd observe the same thing, right? So this is something called static electricity. I think most of you are familiar with static electricity. You've all been sort of shocked when you walk across a carpet and you put your hand to the doorknob. So where does that shock come from, right? Well, about 200 or 300 years ago, scientists were wondering that same question, right? And actually, Benjamin Franklin was a big pioneer in this field of study. And they came up with this model, right? And the model has to do with positive and negative, right? So they came up with these rules. They said matter can actually, you can do certain things to matter in which you create these positive and negative attributes, okay? And if you have two things, and one is positive and one is negative, and you put them close to each other, they're going to stick together, right? So if these two things are charged, one's positive, one's negative, they're attracted, okay? And then the same thing if you have two of like charges, right? So if you have one thing that's got negative attributes and the other thing's got negative attributes, you put them together, they're actually going to repel, right? So they came up with these rules, right? And that's where we come up with this idea that opposites attract, right? Positive and negative attract each other, and like charges repel. So positives will actually repel each other, and negatives will repel each other too. Well, after we kind of sort of came up with this successful model, scientists actually were able to utilize that model and actually do some pretty cool things with it. And so this first lesson is going to be on circuits, right? And really, before we talk about circuits, we should probably talk about batteries, right? So let me share my screen here. Okay, screen. This is lesson 1 in unit 9. So you guys will see a new section on circuits and then a lesson 1 in that section, right? And I put some pictures here, here so we could kind of discuss, right? So this is a kind of a picture that you might be used to seeing, right? After you rub a balloon on your hair, we've all done this experiment, right? The balloon actually takes off some negative charges and it leaves these positive charges on your head, and then when you put them together, they actually attract. This is where we get that idea that opposites attract. Batteries are actually a really good example of this, right? So a simplified sort of model of a battery is that on one side of the battery, you have a buildup of positive charge, and on the other side of the battery, you have a buildup of negative charge. Now, there's a barrier between the battery, right? The positives, the negatives want to get together with the positive charges, but they can't because of the barrier. But if you were to connect the battery with a wire, right? So from the positive side down to the negative side, that would give the negative charges a way to get to the positive charges, right? So, and this is something that back in it was Thomson that came up with this idea that actually, if you matter is made up of atoms, right? And these atoms have both positive and negative charges inside of them, and it's actually the negative charges that are the mobile charges. The negative charges are a little bit smaller and they can move around, whereas the positive charges just stay fixed. Okay, so this is kind of a good picture of it here, right? So this is an example of metal, right? And metal is a very conductive substance, meaning that charge can flow through the metal very easily. And so if you picture these metal atoms that are together in this sort of organized structure, they call it a lattice structure. And then the negative charges can actually sort of buzz around like little pinballs in a pinball machine and move around. They're free to move around inside of a metal, right? Here's another sort of picture of it, right? So you've got these metal atoms in a very organized lattice, and then these negative charges are kind of dispersed randomly throughout, and they can actually flow. They can go from one side to the other, right? Here's another picture of atoms, right? So the nucleus has the protons and neutrons, and then you've got these electrons that can actually flow in between the atoms, right? And so this is the basis of electricity, right? This idea that electrons or negative charges can flow from one place to another. What we're going to do today is you're actually going to build your own circuit, okay? So before you build your circuit, you should know some terminology, okay? First one is you're probably familiar with it, which is the battery, right? And that provides what's called an electromotive force, right? It pushes the electrons, the electrons are pulled towards the positive side, right? So that causes sort of a capacity to make something happen. You need wires that are made of metal, right? So they're conductive. You need an LED, right, or a light bulb, okay? LED stands for light emitting diode, but it's the same concept as a light bulb. When you pass electrons through the wire, they heat up the wire, and when the wire gets so hot, the wire will actually start glowing. It's called black body radiation, and it's actually going to release radiative energy. You get a transfer of electrical energy to radiative energy, okay? The other component that you're going to need inside of your circuit is it's called a resistor, okay? Now, there's certain materials that electrons can't flow so easily through, and that's what we call resistive or non-conductive materials. If you put a resistor into a circuit, it's going to actually slow down those electrons. Okay, so another couple of terms that you might not be so familiar with. Current is the flow of charges through a conductive material. Think about like a river flowing. Voltage is how much those charges want to flow. So it's almost like a potential energy that pushes charges through, right? It's the voltage. Think of your battery, right? The battery has a certain voltage on it. That's how much those electrons want to be pushed through the circuit. Okay, we're going to be using a resistor and your LED. So what you're going to do is you're going to click on this link. It's going to take you to the circuits webpage, and you're going to build your first circuit. Now notice you've got all the 5 components here inside on the left-hand side, so you can use these to build your first circuit. The purpose is that you're going to play around a little bit. Okay, I made a sort of a sample here for you. So if you put all of these in, okay, this thing down here is called a switch. Switches are handy when you want to stop the flow or start the flow of electrons going around your circuit. Okay, so go ahead and play with that, and then I want you guys to do these 3 activities, right? So make a circuit, take a screenshot, tell me how you can change how fast those electrons are flowing through, and then I want you to make a circuit that kind of simulates Christmas lights. There's my Christmas lights there. Beautiful. Okay. All right. Good luck. And if you have any questions, I'll be here at the end of class. All right.